Searching through all kinds of various content in your Flutter app is something you'll likely have to implement one day. A successful search implementation needs basically two things: a usable search history and also the search bar widget. Now we are going to take a look at the most extensible and good-looking way to do this. Hello, welcome to the Reso Coder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this project, we are going to build a simple app which will contain the basic building blocks of a good search implementation. And of course, there are many ways to build a search thing in a Flutter app, but we are going to focus, at least in the UI part of things, on a package called Material Floating Search Bar. So this is how it looks like and how it operates in a finished app. So this is the app we'll build. We can search for a new term, and search for it. Now we're going to get search results. Of course, this is just a demo app, so the search results don't look really fancy. They just are 50 results, numbers from 0 to 49, of course. And yeah, so that's it. And we can also tap on an already existing search term from the history. So for example, Flutter. And when we tap on Flutter, it's gonna be taken to the top of the search history. So the most recently used items are first. And then there is also a limit on the amount of items in the history that we can have. So if we type in another term, the last previous term was removed. So again, the last term is widgets. We type in hey, search for it, and widgets is now no longer present in the history because there is a limit of 5 items in the history. And then also you will be able to delete individual terms like this. So this is the extent of the functionality of the app we are going to build. There is a bunch of code which is not really so important to what we are trying to accomplish here, but it's still necessary to have it so that you can have the app running. And to get all of this code, which you can actually now see on the screen, including this search results list view, just go to the written tutorial from the link in the video description, which contains the link to the starter project on GitHub. And also in the written tutorial, you can find all of the code written in this video, links to the libraries, and overall go through this lesson at your own pace. We are first going to focus on the search history and logic part of things, and only then are we going to add the floating search bar from the package, which is also linked in the written tutorial. The way we are going to implement history will be quite simple. We want to keep it down to earth by just operating within the state class. So we're going to just use stateful widget for state management. And also we are not going to persist the history. We're just going to use a simple in-memory list. That's because there are literally hundreds of ways you could take this simple search history project and apply any kind of state management solution you like, whether that's change notifier, block, state notifier, I know, get, X. I really don't know what else you could apply here when it comes to state management. Then the same goes for databases. You can use Moore, SQFlite, Sambast, Hive, all kinds of things, shared preferences. And therefore, it's just best for me to demonstrate something on the simplest case. And then, as you will see in just a bit, you're going to be able to take all of the code written in this video and change it just a little bit and apply it to your needs with, for example, Hive database and change notifier for state management. It's totally up to you. The code that we are going to write in this tutorial is going to be very easily changeable to your particular needs. So let's start. We're going to need to define the history length, which in our case is going to be limited to 5. So let's create a static constant history length equal to 5. Then, as we are going to operate with just a in-memory list, let's create a list of strings, search history, starting with an underscore, and let's make it equal to an empty list, or actually we can make it equal to some predefined history so that we always don't just need to refill the history when we hard restart the app. So I'm gonna add the search terms Fuchsia, Flutter, widgets, and showSearch to the history. So this search history with an underscore is the raw history that we are now going to access from the widgets, from the UI, and is also pre-filled with values. Then additionally, we want to have another list of strings, and this is going to be called filtered search history. This one is going to be filtered and also ordered, and this history field is actually going to be accessed from the widgets, from the UI. Filtering simply means that as we start typing, so let's add another term here, starting with hello, for example. This is going to be a good one. And as we start typing H, showSearch is going to disappear, sadly. When we type E, both terms will remain here because the start string of the terms is HE. And then when we type L, only hello will remain and hey will disappear as well. So this is the filtering. And when it comes to ordering, well, we want to order the most recently used items to be first, to appear first in the list. The way that we are going to do the ordering actually is going to be very, very simple, and I think it's quite clever. Basically, whenever you add a new item to a list, it's added to the end of the list. So new item gets added here to the very end of the list. And the way we can show the newly added or newly used items at the top of the list here is just by simply reversing the order of the list. So we're going to call reversed. That's it. This is how we're going to order the list, just how we want it to be ordered. And lastly, we also need to have a string selected term. This is going to be needed for when we actually, well, select a term so that we can display the search results for the selected term accordingly. Let's first tackle the problem of filtering the search terms. We're going to create a function returning a list of strings, filter search terms, and it's going to take in an optional required name parameter. So actually it's no longer optional when it's required. Required string filter. In case that the passed in filtering string is not null or it's also not empty, so if filter doesn't equal null and filter is not empty, we want to do just what I have described as I was showing you how the filtering actually works. So we want to take the search history, so return search history, the raw one with an underscore. We want to reverse it so that it's ordered properly. And then we want to say where, so that filtering can actually take place, where term starts with filter. As easy as that. And then we want to convert it to a list because where and reversed both return an iterable, but we want to have a solid list in here. So this is pretty self-explanatory. It orders things so that the most recently used items, search terms, are being displayed first in the UI eventually. And we also filter it with the where function. Otherwise, so else, if the pass in filter is in fact null or it's just empty, we do not want to filter anything. So we're just going to return search history reversed, and also to list, of course. And also I've just noticed that for some reason here's a semicolon. Let's remove that, and now we are golden. Adding search terms is not gonna be as simple as calling add on a list like this, because we want to ensure that there are no duplicates in the history. And also, if the term we are trying to add to the history already exists in there, we instead just want to reorder the already existing term to appear first in the UI. So, in other words, when we, for example, try to again search for Flutter by typing in Flutter, but Flutter already exists in the history, what we want to do is to move it down so that effectively we're going to move it up in the UI, because as you know by now, we are using a reversed list. So this is what we are trying to accomplish right now. So let's create a function which is going to return void add search term, and we need to accept a string term. So we do not want any duplicates in the search history, so we are first going to check if search history contains term. And if it does contain the term, well, what we want to do is what I've just described. We want to put the already existing search term first. For now, let's just write a bit of a pseudocode, which is not going to compile just yet. Let's just write put search term first and pass in the search term. We're going to implement this method in just a little while, but it's pretty apparent what this method is going to do. And then we want to short circuit the execution of the method. So let's just return. Then, if the history doesn't contain the term we're trying to add already, we're just going to add a search term to the history. So search history add term. And now what we mustn't forget to do when we are adding new search terms is to limit the amount or the length of terms that's allowed in the history. As you remember, we have set it to 5. So what we are going to do is check if search history dot length is greater than history length. If it is greater, then we need to remove the excessive old search history terms. We are going to apply a very simple algorithm, which is called least recently used, which means that we are going to remove the least recently used search term if we go over the history limit. To do that, we're going to say search history remove range. We're going to say remove range because technically we could be removing multiple terms at once. It's probably not going to happen because, you know, we are adding new terms one by one, so we are probably going to removing terms also one by one. But just in case that we have some preceded values in the history, let's stick with remove range. And we want to remove the oldest, so the least recently used items, which in the case of the raw search history, start at the beginning of the list, so 0 index. And we want to remove until search history dot length minus history length. This subtraction produces the count of excess items in the history. And lastly, we have just updated the search history, which is a state, but actually what we are gonna be using from the UI, from the widgets, is the filtered search history. So we also need to update that by calling filtered search history is equal to filter search terms, and the passed in filter will be null. You may be asking, how do we know if the filter is truly null? What if the user has already typed in something into the search bar? Hello again. Well, if this happens and we are adding a term, it just totally doesn't matter, because once we search for this term, the search bar is either way gonna be reset without a term again. So that's the reason why we can call with a null filter at all times when we add a new search item. Again, this implementation of adding your search terms and also of the filtering will depend a bit on the database you choose to use and also on the state management solution you choose to use with your app. But the principles and even the basic code will remain the same. When it comes to deleting the terms by clicking on these X's next to the names of the terms, that's pretty simple. We're going to create a void method again, delete search term, accepting a string term. And what we're going to do here is just say search history, remove where, and where the term t is equal to the passed in term. And lastly, also, we want to update the filtered search history, because again, this filtered search history is what's actually going to be used from the widgets. So we need to always update that in sync when we update the search history, which is the private field, which is not going to be used from the widgets. Let's now think about how we're going to implement the put search term first method, which is very important here, so that we can have a nicely functioning history which displays the most recently used terms first in the UI. Let's create a void put search term first, which will accept a string term. The way we can implement this simply is actually by just first deleting the search term and then by adding it again. So add search term. Why? Well, because deleting a search term is gonna delete it from wherever it is in the history. So for example, Flutter, it's gonna be deleted from history wherever it is. And then adding it will always just add it to be the last one in the raw search history. So again, this means that it's first in the filtered and ordered search history. This approach is perfect because we are just storing simple strings in the history. Now, of course, you could create your own class and store some datetime or timestamp object inside of it and update the timestamps of when they were last used and so on. That's totally doable, but I think that this simple approach works just fine and it's performant. There's no issue with it. So we're going to stick with this simple approach of just first deleting and then adding the search term anew when we try to put it first. Additionally, let's just initialize the filtered search history from init state, because as of now, it's just null by default. So we're going to say filtered search history is equal to actually this null thing. So filter search terms, filter null. And now we can go ahead and implement the search bar UI. Also, again, if you would like to look at this code at your own pace, to copy it into your project and so on, check out the written tutorial from the link in the video description. As I've already mentioned, we are going to use the material floating search bar package. So let's add it to the pubspec. The version we are going to use is 0.2.6. You can also get this version and all of that, also the link to the library from the written tutorial. So let's save the pubspec, and here we go. We can now use this package from our Dart code. Unlike with the default app bar, which you usually put into the app bar parameter or property of the scaffold, what we are going to do with the floating search bar is that it's actually going to be wrapping the body of the scaffold. So the body of the scaffold currently is just a simple search results list view, which just doesn't display anything at this point. And we're going to wrap it with a widget called floating search bar. Let's import that from the package, and the search results list view is now going to be the body of the floating search bar. And actually, let's run the app on an emulator, because currently we are running the already pre-built app. The app doesn't look like much right now because we are actually missing some required parameters for the floating search bar, but we are going to handle that later on. For now, since we want to also control the search bar programmatically, for example, close the history view with the history terms displayed whenever we add a new search term, or when we click on an already existing search term from the history. To do that programmatically, we need to have a floating search bar controller field. So let's just call it controller, and we're going to initialize it in init state. So controller is equal to floating search bar controller. And now we're going to put this controller as the controller of the floating search bar. And also we mustn't forget to dispose of the controller inside of the dispose method. So controller.dispose. Now I'm not sure if you have noticed, but in the finished app, when we scroll down the list, the search bar gets hidden. And when we scroll up, it gets shown again. This behavior can only happen if we wrap a scrollable or something which contains some sort of a scrollable list view, for example, like this search results list view we have here, inside of a widget called floating search bar scroll notifier. This is going to ensure that the notifications about scrolling from the list view right here are going to be also translated into notifications which affect the floating search bar. And then the search bar is going to be automatically hidden and shown depending on how the user scrolls the list view. There are a bunch of cosmetic fields which need to be set on a floating search bar too. So one of them is transition. This is what you see when you open up the search bar. So this brief transition, when you have more items in there, it's more visible. So it's sort of a circular floating search bar transition, and this is precisely how it's called. I'm actually just going to copy its name, paste it here. You can always get the code from the written tutorial available from the link in the video description. Then let's talk about physics for a while. So the physics for the search bars pop up here. They by default are the material physics, which shows that overglow, or how it's called. But we actually want to have the iOS style physics, which are the bouncing scroll physics. So again, I'm going to copy the code from the written tutorial, bouncing scroll physics. These physics are not applied if you have low amount of history items inside of there. But if you have more search terms in the history, then scrolling will take place, and this is when you will see the physics. So we want it to bounce. The next thing is the title. So the title is what you see when the search bar is not active, let's say. So when the user does not click on it. Basically, whenever we have already searched for something, for example, transition or reso coder, we want to show that selected term in the title. But if the selected term is null, so that means the user has not selected any term yet. We just want to show the search app. And also it's quite important to style this text properly. Headline 6 is actually the style for the default bars title. So we're going to be using this headline 6 from the material theme. Lastly, we have the hint, which is the thing that gets shown when you actually activate the search bar. So search and find out, this is what we want to be shown in there. It's also quite useful to be able to clear out something that the user has written. So for example, we mess up, we write something like this. We want to be easily able to just clear it up. So we have this X icon over here. We press that, gets cleared up, and we can type in new things. So this action is actually a floating search bar action, which is a very special type of an action, search to clear. So let's add actions, floating search bar actions dot search to clear. And of course you have multiple other actions which you can add there. You can even create your own actions, but I think that we're just fine with only the search to clear action. It's quite useful actually, and also it has very nice animations by default, so that's definitely a nice touch. How are we going to find out about the text that's changing inside of the text field here? And how are we going to find out when a user submits this query? Well, we need to find out about these actions. And that's exactly what callback methods are for. So we have one called onQueryChanged. And when the query is changed, what we want to do is to refilter the search terms based on the new query. So we're going to set state, and we're going to set filtered search history equal to filter search terms based on the query being the filter. Then when the search term is submitted, we want to take this query and set state. Obviously, when the search term is submitted, we want to add the entry to the history. So we are going to add search term query. And also, whenever something is submitted, we want to automatically select it so that it's going to be searched next. See, search next is now going to be searched next. So let's say selected term is equal to query. And if I could spell selected term. And lastly, we're going to use that controller to programmatically close the search bar. So we're going to say controller.close. By now we have set up everything except for the UI that's actually responsible for showing the search history terms. So in order to implement that, there is the builder parameter, which gives us a context and a transition. The floating search bar gives us a completely free hand at how we want to style this pop-up over here, or I'm not sure if it's even a pop-up, but this UI element, we can style it however we want. So we basically want to have rounded corners. We want it to be white, at least the background should be white. And also, whenever we press on the list styles here, which we are going to add in just a moment, there should be this ripple effect. So we should see the ink. That means that we need to use the material widget because material allows us to use this ink. So we're going to return clip rect because we want to clip the material, which is going to be child of this clip rect. And we want to clip it so that the borders will be circular. So we're going to say border radius is equal to border radius circular, and the radius is 8. This is just a general nice number to use when you are dealing with circular borders. And then the child of this clip rect will be material. Its color will be colors white, just simply hard code it in there. And let's also deal with elevation to be 4. It's not very visible, but I think it's slightly more good looking than if you don't add it here. Now we're going to take care of the actual child of the material in just a bit, but for now let's just put a placeholder in here with fallback height of 200, and let's see how it looks. So actually I'm going to switch to this app. Now it's actually displaying properly, and when we tap on the search bar, we can see the placeholder with rounded corners, and it's white background, so that's nice. The thing with the content of this builder is that we're not always going to display only the filtered search history. For example, when I delete all of the search terms, we want to show this start searching message. Then when I type in something and it's not present in the history already, we want to show this little hint, or however you want to call it, which contains exactly the string which we are typing above, like this. Then when we tap on it, we're going to add this search term, right? And only then we want to show the history which is filtered, right? So something like this. When we type in A, only A will be displayed. So this is only the third case. We have 3 cases of what we want to display in there. This means that we are going to use some conditional logic to satisfy the different conditions and display different widgets according to them. This in turn means that we need to break out our code into another build method with a builder widget. You could also create your own custom widget class, but I'm just too lazy to do that, so let's just stick with the builder as a quick fix. So actually, here we go with the builder. Yeah. Let's first focus on when we want to display the simple start searching hint to the user. Well, that's going to happen if the filtered search history is empty, and also controller.query is empty. So we have nothing in the search history at all, or at least not in the filtered search history. And also actually the query is empty, so the user has not typed in anything. In that case, we want to return a simple container with a text, and it's styled nicely. And because I don't want to bore you, I'm just going to paste it in here. You can study it at your own pace from the written tutorial, which is available in the link in the video description, as always. Then the next special case, which we have already gone through, is when you type in something which is not present in the history at all. Then this gets displayed, which is a special list style, and when you tap it, you're going to search for this term. So you're going to add it to the history also. So this condition happens, so else if the filtered search history is empty, but in turn the controller's query, the typed in thing by the user, is not empty. In such a case, we want to return a list style, which will have title set to a text containing the controller's query. Then the leading icon will be just a constant icon, icons.search. And now we're getting into the interesting stuff, the onTab method of this special list style. Actually, the content of the onTab method, the logic which should run, is identical to when you are just simply adding a new search term through onSubmitted. And now, I could just create a brand new method, a helper method, which would encapsulate this functionality so that we don't have any code duplication. But actually, this is just a tutorial focused on showing you how to build a search bar. So I'm just going to blatantly copy it over here. And instead of query, we need to write controller.query. And also, let's not forget about our semicolons. Lastly, inside of the else clause, we want to display all of the search history terms inside of a column. We are not going to be using a list view for a bunch of reasons which are more outlined in the written tutorial, but basically, there are just issues with list views. We would need to disable scrolling, we would need to shrink wrap it, so I think it's just easier to use columns. So let's return a column. The catch with a column is that actually it needs to have main axis size set to main axis size dot min. And now the children of the column are going to be derived from the filtered search history. So let's say filtered search history dot map, and from this map function, which will give us terms, so term, we're going to return for each and every term a list style, which will be having a text inside of the title that is going to just display the term. As always, you can get this code from the written tutorial. Next, the leading icon in the list style will be showing a history icon like this. Then the trailing icon is actually going to be interesting because it will contain some logic. It will not just be any kind of an icon, it will be an icon button. And this icon button, when it's pressed, is going to delete the search term in question. And then lastly, we are going to add the onTap callback function, which will put the search term first and also select the term, and also close the search bar programmatically. So this is happening because whenever we actually select a term, of course, we want to search for it. So that's why we select it and also put it first, because the most recently used items should be displayed first. So with this done, let's go to the app and let's actually go to the app we are building currently. We have some errors and those are quite simple. That's because we have an error here, which says that basically we need to return a list of widgets, not an iterable of list styles. So we just need to find the end of this map. Right here it is. And we need to call toList on it. And now what's going to happen is that it all works. We can see that the app is now successfully built. We can search for resocoder and nothing happens. Why? Well, that's because we are not passing in the selected term, this one, into the list view. So let's scroll down, and here inside search results list view, we are always passing in null. So let's now pass in the selected term from the state. Save that. Now actually when I come back, we should see the search results being displayed in the app properly. But here's the catch. Have you noticed something weird? I'll wait maybe 1 second. The weird thing is that we are displaying 50 search items, but the first one we see here is actually the second item because the ordering starts from 0. So we should see 0, 1, 2, 3, but we see only 1, 2, 3. What's up with that? Well, the thing is that you can currently not even see the very first result because it's hidden by the search bar. When I actually try scrolling like this, you can see something up top. You can see that something is in there, but now it gets hidden behind the search bar just perfectly. What we need to do is to apply some padding on this list view so that the very first search result is actually going to be visible. And we could apply some generic padding, some hard-coded values, but it's always best to apply padding which is dynamically gotten. So basically we need to apply a padding of the height and also some vertical margins of the search bar. So how can we get these dimensions of the search bar? Well, it's very, very simple with the package we are using. We can actually get the state of the floating search bar by just simply calling floating search bar dot off and passing the context. This is going to grant us the floating search bar state. Let's just store it inside final fsb for floating search bar state. And now we're going to say that the padding of the list view will be edge insets only, and we only want to set the top inset, and this is going to be fsb.height, but this is not enough. As you can see, now we can see the 0 index, but still it's weird, it's hidden quite a bit behind the search bar. That's because we also need to take care of the fsb.margins.vertical. Once we have that, we can see the 0th, I'm not sure if you can do that, but 0th search result in its full glory. And that's it. You have just learned how to implement your own solution of a search bar in a very simple manner. You are going to be able to take this code which we have written here and apply it to any kind of project you want with any kind of a state management and database solution you want. Of course, you will need to change some things, but the principles and even the basic code will still remain the same. So to go through this tutorial at your own pace once again, and also to get the code, check out the written tutorial available from the link in the video description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, link is also in the video description by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you, give it a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.